In this example, I need to find any vertical asymptotes, horizontal asymptotes, slant asymptotes, and any holes for the rational function f of x equals x squared minus 4x plus 3, all divided by the quantity x plus 1. To analyze this function for vertical asymptotes and holes, I need to see if this function can be simplified anymore. So looking at the numerator, will this expression factor? Yes, I think it will. It's a simple one. The leading coefficient on the x squared is a 1. So I know I'm going to need an x and an x in my parentheses. My two numbers multiply to a positive. That says the signs in these parentheses have to be the same. And since they add to a negative, both of those signs have to be negative. Now I need two numbers that multiply to 3 and add to -4. Well, I think -1 and -3 will work. And that is divided by the quantity x plus 1. Now, does anything simplify in this expression? No, I have no common factor to reduce between the numerator and the denominator. And since holes come from reducing a common factor between the numerator and the denominator, I know in this case there are no holes. But I still have a denominator here, so I know I'm going to have a vertical asymptote. And vertical asymptotes come from setting the denominator of the simplified expression equal to 0. So I'm just going to set x plus 1 equal to 0, subtract 1 from both sides, I get x equals -1. So I know this rational function has one vertical asymptote at x equals -1. Next, I need to look for horizontal asymptotes and slant asymptotes. To do that, I need to find the degree of the polynomial in the numerator and the denominator of my rational function. Well, for my numerator, what is the degree? What is the highest exponent on any of the x's? It's a 2. And for the denominator, what's the highest exponent on any of my x's? It is a 1. So in this case, the degree of the numerator is 1 more than the degree of the denominator, as 2 is 1 more than 1. So that means I'm going to have a slant asymptote. And to find it, we have to complete this division up here. We could do it by long division, but I think synthetic division is so much easier. So in doing synthetic division, you find the 0 that goes with the denominator. X plus 1 equals 0 when x equals -1. So that's the 0 that you put in the box on the top left. And now I need the coefficients and constant term of the numerator here. Do I have any missing terms in the numerator? No, I have x squared, x, and a constant. So my coefficient of the x squared is a 1. So my numbers are going to be 1, -4, and 3. 1, -4, and 3. Leave some room. Now bring down the 1. And then multiply -1 times 1 and put the answer up here. -1 times 1 is -1. Now add -4 and -1, you get -5. Now repeat the process. -1 times -5 is +5. Write the answer up there. So there's my 5. Add 3 to 5, you get 8. That is the remainder on doing the division. Here is the quotient, and that is the equation of the slant asymptote. So the slant asymptote is y equals, now remember this was an x squared term, so this is 1 degree less, so that's going to be x, so my quotient is 1x or x minus 5. So the equation of the slant asymptote is y equals x minus 5. And the last thing we need to look at is, does this function have a horizontal asymptote? Remember, rational functions cannot have both a slant asymptote and a horizontal asymptote. So this function has no horizontal asymptotes.